This is a video for section 4.7, which is on piecewise functions. This is also the last video for chapter 4. Your learning targets are that you will be able to evaluate a piecewise function and you will be able to graph and write a piecewise function. So over here in the core concept, we have some information about piecewise functions. And so a piecewise function is defined by two or more equations, which create pieces of the function when you evaluate or graph it. So if you're looking at this piecewise function here, we have two different equations. And so when we graph it, you get two kind of like separate pieces. Okay. Example 1 is evaluating a piecewise function. So we have evaluate the function f of x equals x minus 2 if x is less than or equal to 0, or 2x plus 1 if x is greater than or equal to 0. So first we want to evaluate this when x is negative 1. So first we look at the inequalities. Is negative 1 less than or equal to 0, or is negative 1 greater than 0? Negative 1 is less than 0. So since negative 1 is less than 0, we're going to use x minus 2. So I'm going to plug in negative 1 for x. So negative 1 minus 2 gives us negative 3. So that's our answer for this first problem. The second problem says to evaluate it when x equals positive 1. So again, starting with your inequalities, is 1 less than or equal to 0, or is 1 greater than 0? This time 1 is greater than 0, so that means we're going to use the equation 2x plus 1. So I'm going to plug in 1 for x. 2 times 1 gives us 2. Bring down my plus 1, and then 2 plus 1 is 3. So when you're doing these, you're looking at the inequalities to determine which expression you should use, and you're only going to be using one of them. So the value that you're evaluating will only fit into one of these inequalities, and that is the only expression that you then use. Example 2 is graphing a piecewise function. So we're graphing y equals negative x plus 2 if x is less than or equal to 0, and 2x if x is greater than 0. And then we're going to describe the domain and the range. So if you look at the inequalities here, we see that we have a x is either less than or equal to 0, or x is greater than or equal to 0. This 0 is like our boundary point. So I'm going to draw a line here at 0 when x is 0, because that's like our boundary. So we're going to have one type of graph on one side of this line and one type of graph on the other side of this line. So for the first one, we have y equals negative x plus 2. So I'm going to make my xy table here. And my inequality says that these x values are less than or equal to 0. So I'm going to start with 0. And it can be equal to. So I'm going to put a solid point here so I remember that my 0 can be equal to. And then I need to pick x values that are less than 0. So some x values that are less than 0 would be like negative 1, negative 2, negative 3, negative 4, so any of those. So I'm going to do 0, negative 1, and negative 2. So I'm going to plug these into that negative x plus 2 equation. So when I plug in 0, I get 2. When I plug in negative 1, I get 3. And when I plug in negative 2, I'm going to get 4. So now I have these 3 points. So I'm going to go ahead and plot these. I have 0, 2, and that I said was a solid point. These additional points are going to be solid as well. So I have negative 1, 3. And then negative 2, 4. So then I'm going to go ahead and connect these points. When I connect these points, I'm not going past that yellow boundary line. So my graph is going to stop at that boundary line. It's only going to go on the left side of the boundary line. So now I'm going to work on that other equation, which is y equals 2x. So again, I'm going to make my xy table. I'm starting at 0. This time 0 is not equal to, so I'm going to put an open point next to 0 to help me remember. And my x values need to be greater than 0, so I'm going to use 1 and 2. So I'm going to plug 0, 1, and 2 into this equation. So 2 times 0 is 0, 2 times 1 is 2, and 2 times 2 is 4. So now I'm going to plot these points. So 0, 0 needs to be an open point because it's not equal to. However, 1, 2, and 2, 4 can be solid points because those are equal to, they're part of my graph. So then I'm going to draw in my line here. Again, it's not crossing that yellow boundary line. It's only going to be on the right side of my graph. So the last part of this problem is to determine the domain and the range. So again, I'm going to put my D for domain and my R for range. So looking at my inequalities here, my piecewise function incorporates every value because I have x's that are less than 0, I have x's that are greater than 0, and my x can be equal to 0. So my domain here is all real numbers. So I'm going to put that fancy R here for all real numbers. My range is where it gets a little bit tricky. So if you're looking at your graph, the lowest y value that I have is the 0, 0 point right here. However, that 0, 0 point is not equal to. So when I write my range, I need to write that y is greater than 0. And it's not equal to 0 because that's an open point there. So the range for this graph is that y is equal to 0. Because as I continue to go on this graph, all of these y values have points on either the y equals 2x graph or on the y equals negative x plus 2 graph. So example 3 is the opposite of what we were doing in example 2. We are writing a piecewise function. So if you look at this graph right here on this on the y-axis, we have our boundary line, okay? So we have one graph that's going to the left and then one graph that's going to the right. So when I look at these graphs, I want to look for my y-intercept and I want to look for my slope. So this point right here is my y-intercept of that first graph, and that's at -2. So now I want to look for my slope. So I have this other like good point right here. So if I count my slope, I'm going to go down 2 and right 2. So that's going to give me a slope of -2 over 2, which is going to be -1. So to write this line, I have y equals -x minus 2. So now writing it into that piecewise function, I have -x minus 2. And if I'm looking here, this is on the left side of my graph. So I have to figure out what x values I'm using here. So these x values are less than 0. My bound is at 0, and that was a solid point. So when I write my inequality, I'm going to use x is less than or equal to 0. So now we're going to look at the other side. So here is my intercept, and that's at -3. So I have my y-intercept at -3, and now we need to find our slope. So this looks like a good point right here. So if I count up, I'm going up 2 and over 1. So my slope is 2 over 1, which is just 2. So my equation here is going to be y equals 2x minus 3. So over here in my answer, I'm going to write my 2x minus 3. And then this time my inequality, this is all x values that are greater than 0. Again, my x equals 0, that's my bound. So I'm going to write x is greater than 0. And this time it's not equal to because we did not have a solid point. We had an open point there. So this is the piecewise function that's represented by this graph.